Okay, welcome year 10s to this first video in our probability unit. So you've done probability before, you've done it for a number of years. So in this first lesson, it's really just going to be a review of the basics, or a review of the key things that you'll need to know as we progress through the topic. So the first thing, the first key term that we might look at is sample space. So this is where you've got all the possible outcomes that might come about from an experiment. And we use that word experiment just really to refer to any scenario where there's probability. So in terms of the sample space, say for a dice or a six-sided die, we would list it with these curly brackets, and within the curly brackets, we list the different options or different outcomes that are possible from the experiment, and then we end it with curly brackets again. So if you've got lots and lots of numbers, sometimes you can just use little dots to in between. So for example, if I wanted the numbers 1 to 100, I might just go like 1, 2, 3, dot, 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 100. Just so you don't have to list every single one, but that's just an example that you might come across. So once you've got your sample space, the sample space is important because when we're finding probabilities, we need to know how many outcomes are possible. When you are calculating a probability, what you're going to find is your answer, your result, is always going to be between 0 and 1. We can't have any probabilities greater than 1. 1 is our maximum because probabilities, or events, I should say, that have a probability of 1 are certain, so they will happen. On the opposite end of the scale is 0. So events with a probability of 0 means it just cannot happen, will not happen. So impossible, in other words. Because we're working with a scale, that means that right in the middle we have an even chance. So this is like tossing a coin. You have half the outcomes are heads and half the outcomes are tails. So you have a 1 in 2 chance, and that's what's listed underneath. Now your probabilities can be written as fractions, simplified fractions. Make sure we're always doing that. Or they can be written as decimals. On this scale here, they're written as decimals, but it's not incorrect to leave your answer as a simplified fraction. So in terms of things that are certain, well, that the sun will rise tomorrow. And then, of course, things that are even. My example was flipping a coin. Things that are impossible. Well, I'm sure you can think of loads of impossible events, like man being able to fly, things like that. I'll let you think of your own examples. So calculating the probability of an event. So we do need to know the total number of outcomes. And we do need to know how many favourable outcomes there are. So for example, if we're looking at this particular one here where we've got a letter being chosen from the word television, so assuming chosen at random. So imagine we had each of these little letters on a piece of paper and we put them into a hat, and you're picking one out of a hat. We want the probability that the chosen letter is an E or an I. So what we want to do is identify how many E's and I's we have. That's our favourable outcomes. Then we want to do over our total number of outcomes. So I'll just set this up over here. So we've got 4 that are favourable. I might just clean that up a bit because I should be using the right notation. We put PR and the event is an E or I. And I'll just move that over a little bit further. So the probability of getting an E or an I will be 4 possibilities out of the total. So this is where we count up how many letters there are in this word. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Lovely. And that will simplify to 2/5 or 0.4. Now keep in mind that you do have your calculator. So if you wanted to, you could have done 4 over 10 like that and press enter, and that will show me that it's 2/5, or you can press Control Enter and it will show me that it's 0.4. So that's how we're going to approach questions like this. You're going to count your favourable outcomes and then you are going to put it over the total outcomes, keeping in mind always that we simplify fractions. Now, sometimes when we come across probability scenarios, the probabilities actually come from the experiment. So if we have a look here, we've got an experiment tossing 3 coins and counting the number of heads, and these are the results. Now, using these results, we're going to calculate the probabilities from that. So this is what we call experimental probability. So using this, find the probability that the outcome would be 1 head. So we've got 100 times the coins were tossed, the 3 coins were tossed, and we want for 1 head. So we're looking at this one just here. So what we do is we look at the frequency in the experiment. So this happened 40 times. Out of the total, we had 100 times that the experiment was run. So again, we can simplify 4 over 10, which is 0.4, or just like the previous one, you could have written that as 2 over 5. This one here, more than 1 head. So now we want to have a look at these 2 here. More than 1 does not include 1. So we don't want to include the 40 and the 11 here. What we want to do is look at just this part. So how many times did more than 1 head come up? Well, we've got 36 and 13, so we add them together. So it happened 49 times. So the probability of greater than 1 head is what I'm going to write, is 49. Hopefully you can see that. Out of 100. Now again, if you weren't sure whether you could simplify that or not, you could just check it in here. But what we're going to see is that stays as doesn't simplify. So 49 on 100 is 49 on 100, but of course as a decimal is 0.49. So there we have a situation where we needed to use the experiment data and a situation where we can just use the favourable outcomes and the total outcomes. So it's really no different. You are still looking at what's favourable, but sometimes if you are provided with a table of data like this, you'll use the data to generate your probabilities. So I'm going to stop there so that you can have a go. What you'll see is we are looking at 8A, review of probability. If you want to, there are additional examples in your text if you are still feeling like you need a little bit more help. Maybe have a look at those examples before you start the exercise, which you can see starts here.